Hello everyone, I am Nazma Makandar. I am studying in BSc 4th SEM SSGFCC Narugun. My assignment topic is polymers. Introduction, definition, classification, degree of polymerization. Definition of polymer. Polymers are large macromolecules made up of repeating units called monomers. They are formed by chemical reactions known as polymerization. They have high molecular weight. Examples: plastics, rubber, nylon, DNA. Definition of polymers. Polymers are very large molecules made when hundreds of monomers join together to form long chains. The word polymer comes from the Greek word poly meaning many and meros meaning is parts. Example: polyethylene. Key characteristics: high molecular mass, repeating structural units, can be natural or synthetic, show different physical property like elasticity and strength. Classification of polymers. First one by origin, second one by monomers, third one by thermal response, fourth one by mode of formation, fifth one by structure, sixth one by applications and physical properties, seventh one by tacticity. By origin is further divided into three types. The first one, natural polymers. Polymers which are isolated from natural materials are called as natural polymers. Example: silk, wool, natural rubbers, cellulose, starch, proteins, etc. Second one, synthetic polymers. Polymers synthesized in laboratory from low molecular weight compounds are called as synthetic polymers. For example, nylon, threonine, polyethylene, polysaccharidine, synthetic rubber, nylon, PVC, bakelite, and Teflon, etc. And third one, semi-synthetic polymers. The polymers obtained by a simple chemical treatment of natural polymers to improve their physical properties like lactose natural tensile strength are called as semi-synthetic polymers. Example: cellulose acetate and cellulose nitrate, where can see that the formula and structure of cellulose acetate. Second type of classification by monomer. Monomer further divide into two types. Homopolymers. A polymer consists of identical monomers is called as homopolymer. Example: polyethylene, PVC, polypropylene, nylon 6. And second one, copolymers. A polymer consists of monomers of different chemical structure are called as copolymers. Example: nylon 6,6. And third, classification by thermal response. Thermal response, thermal thermoplastic polymers. They are easily molded in a desired shape by the heating and subsequent of cooling and room temperature. They are soft in hot and hard on cooling. They may be linear or branched chain polymers. Example: PE, PVC, PS, PP. And second one, thermosetting polymers. This polymer is hard and infusible on heating. These are not soft on heating under the pressure and they are not remolded. These are cross-linked polymers and are not reused. Example, backlight. The fourth classification is by mode of formation. It can be shows the addition of polymers. The polymers formed by the additional of monomers repeatedly without removal of byproducts are called as addition polymers. These polymers contain all the atoms on of monomers, hence their molecular weight are integral multiple of monomer units. Example, Teflon, polyethylene, polypropylene, PVC. And fifth classification is by structure. It further divided into three types. Linear polymers. First one, linear polymers. In these polymers, monomers are linked with each other and form a long straight chain. These chains has no any side chains. Their molecules are closely packed and have high density, tensile strength and melting point. For example, HDPE and nylons. And second one, branched polymers. They have a straight long chain with the different side chains. Their molecules are irregularly packed, hence they have a low density, tensile strength and the melting point. For example, LDPE and LLDPE. And third one is cross-linked polymer. In these monomeric units are linked together to constitute and 3D networks. The links involved are called cross links. They are hard, rigid, and brittle due to their network structure. Example, backlight and melamine and formaldehyde resins and vulcanized rubbers. Then sixth application is by application and physical properties. Is further divided into three types. Fibers. If polymers is drawn into a long filament like material whose length is at least 100 times its diameter are said to be converted into a fiber. They have high tensile strength because of high intermolecular attractivity force like hydrogen bonding. Highly crystalline. For example, nylon, trilene. Second one, plastics. Polymers is shaped into a hard and rough utility articles by applications of heat and pressure is known as plastics. Here the intermolecular force between the polymeric chain and intermediate between the elastomers and fibers. They are partially crystalline. For example, polysaccharide, PVC, PMMA. And third one, elastomers. They are solid with rubber-like elastic properties. Here the polymeric chain are held together by the weakest intermolecular forces, so they are highly amorphous in nature. These weak binding forces permit them to be stretched. Example, natural rubber, Buna S, Buna and Vancomycin rubber, where we can see the structure of neoprene. The fourth one is resins, low molecular weight polymers which are used as adhesives, sealants, etc. in a liquid form are described as a liquid resins. Example, epoxy adhesive and polysulfide sealant. Let us discuss about polymerization, the process by which the monomer molecules are linked to form a big polymer molecule is called as polymerization. Polymerization is the process of bonding monomer or single unit together through a variety of reactions mechanisms to form longer chains named polymer. As importance of polymers are they exist with the monomers which are small single molecules such as hydrocarbons and amino acids. Degrees of polymerization. Degree of polymerization dp is the number of repeating monomers units in a polymer chain. Formula: dp is equal to molecular weight of polymer divided by molecular weight of monomer. Degree of polymerization, number of repeating units in the polymer on formed is called as the degree of polymerization is N. Polyethylene C2H4, where N stands for DF. Molecular weight of PEM equals to NMO, where MO is molecular weight of monomer. Strength of the polymer can be increased by the increasing its dp. High dp is hard and heat resistant. Low dp is soft and gummy. Importance of degree of polymerization. High dp is equals to greater strength and roughness. Affects melting point and viscosity. Determines mechanical properties of polymers. Conclusion. Polymers are essential materials used in everyday life. They are Their properties depends on a structure and degree of polymerization. They are widely used in industries like packing, textiles and medicines. And thanks for watching.